In section 2.8a, proving angle relationships, we want to go ahead and add some definitions to our Cornell Notes sheet before we get into the rest of the notes here. So let's go to our Cornell Notes sheet. We're going to jump down here to conditional statement. A conditional statement is a statement that can be written in if-then forms. We're all the way down here. A statement that can be written in if-then form. For example, if it rains, then I will use my umbrella. Not almost any statement can be turned into an if-then statement, but we often talk in conditionals, especially mothers to children, fathers to children, but we don't always say it exactly that way. We might say, if it rains, I will use my umbrella. Notice I left the then out because we don't say always, if it rains, then I will use my umbrella. But you might say to your child, if you throw that, you will be in timeout. And if we write that in if-then statement, if you throw that, then you will be in timeout. So there are a lot of conditionals. If one thing happens, then another thing happens. And this is the basis for all our geometric proofs. Because as we move through the proofs, if one statement is true, then we can conclude from that statement that another statement is true, and then if that one's true, the next one is true, we move on, so on and so forth. So some of this may seem like English, but it's actually going to lead us into our proofs and some ideas that we definitely need basics before we get into our proofs heavy duty. Hypothesis is simply the if part of the conditional. It does not actually include the if. So the hypothesis in this statement is it rains. We don't include the if. The if is like your cue word, and then what comes after it would be your hypothesis. The conclusion then is the then part of the conditional. So that would be, I will use my umbrella. Okay? Then is not part of it. And then we will also talk about the converse. The converse, if you think about converse, the way to remember this, my cheesy way, converse, what do you think of when you hear the word converse? You probably think of high-top sneakers, or now they make low tops. But when Converse first came out, they were only high-top sneakers that mostly the guys that were the skaters, the quote skaters, would wear. Okay, so think about it like this. This is how I think about it. The kids that wear the Converse tennis shoes are flipping on their skateboards. Okay. So that is how I kept this one straight, because there are several other statements too. But the converse is the statement you get when you flip the hypothesis and conclusion. So you're flipping them around. So if we use the same conditional here, we would flip the hypothesis and conclusion. We still say if at the beginning, but instead of saying if it rains, we say if I use my umbrella, then it rains. Okay? So, and then once we write converses, we can talk about if they're true. Are they true to begin with? Are they still true after we flip them around? And what we have learned about those things. So that's only the Cornell definitions that we need for this section. And then we're going to start some of this and finish them up in class. So the first couple examples say, write the converse of each statement and decide if it is still true. So what I'd like you to do actually is do number 1, 2, and 4. Write the converse of each of these statements and decide if the converse is true. So let me do number 1 with you. If two angles are complementary, then they have a sum of 90 degrees. So the converse, remember, the converse is just flipping it. So we would write if, and we can put the subject at the beginning, if two angles, and then go down here, have a sum of 90 degrees, then they are complementary. Now notice the reason I put two angles up here and they down here is just so it would make a little more sense. So the key concept here is that they are complementary, and the key concept here is that they have a sum of 90 degrees. So you're flipping the key concepts, and you may just have to adjust the subject so that it makes sense. So if two angles are complementary, then they have a sum of 90. Is that true? That one is true. How about the converse? So this is the original conditional. This is the converse. If two angles have a sum of 90, then they are complementary. That one is also true. Okay? So that's what I want you to do for number 2 and number 4. Write the converse and then decide if the first statement is true and if the converse is true or false, I should say. And then in number 4, write the converse and decide if the conditional is true and if the converse is true. The rest of this I would like to complete with you. The rest of this I'd like to complete with you in class. What I am going to do is go ahead and give you the other Cornell note sheets or the other Cornell definitions so we can move more quickly through this second part here. So moving on to the definitions on the back side. Definition of congruent angles. Definition of congruent angle is very simple. It says if angle 1 is congruent to angle 2, then that means the measure of angle 1 equals the measure of angle 2. Okay? And it's important, you think, why should we have to do this? But you must convert to equals in order to use substitution in a proof. And since substitution is one of the most used properties in a proof and the most important properties in a proof, then oftentimes you'll have to convert from congruence to equality in order to continue on through the proof. So that reason would be definition of congruent angles. Okay? We're just taking it from congruence and rewriting it as equality. Definition of supplementary says if angle 1 is supplementary to angle 2, then the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay? Each of these has a converse that is also true. So this is where the converse comes into play. So we can flip the statement. If the measure of angle 1 plus the measure of angle 2 equals 180, then angle 1 is supplementary to angle 2. Okay? Or sometimes I'll abbreviate it right. Angle 1 is sup to angle 2, like that. Okay? Definition of complementary, exactly the same, except one small difference, of course. Angle 1 is complementary to angle 2. Then the measure of angle 1 plus the measure of angle 2 equals 90. Now, if you have trouble remembering these, they go alphabetical order, smallest to largest. So complementary, of course, comes first in the alphabet. That's the smaller one, 90. Supplementary comes later on in the alphabet. That's the larger one, 180. And the converse of this would be if the measure of angle 1 plus the measure of angle 2 equals 90, and angle 1 is comp to angle 2. All right. Definition of perpendicular. If we have a diagram that looks like this, A, B, C, and we say if ray BA is perpendicular to ray, oops, putting this in the wrong place. All right, if ray BA is perpendicular to ray BC, then angle ABC is a right angle. So anytime we see this perpendicular symbol, here's the symbol for perpendicular, we should go ahead and mark a right angle in the corner. So if ray BA is perpendicular to ray BC, where they come together, they meet at a 90-degree angle. The converse is also true. If angle ABC is a right angle, then ray BA is perpendicular to ray BC. Okay. Definition of a right angle. And I will probably let's just get rid of that. If angle 1 is a right angle, we'll put a 1 in there. Oops. Then the measure of angle 1 equals 90 degrees. If angle 1 is a right angle, then the measure of angle 1 equals 90 degrees. Okay, so the definition of perpendicular goes from perpendicular to say that it's a right angle. But if you look up the word right angle in the dictionary, it will tell you that it measures 90 degrees. So we see right angle in both of these statements, but it depends on what it's linked with. If right angle is linked with perpendicular, then that's definition of perpendicular. If right angle is linked with 90 degrees, then that's definition of a right angle. So you have to be careful when you see the right angle, because the right angle fits with two different definitions. The converse is also true. If the measure of angle 1 equals 90 degrees, then angle 1 is a right angle. Okay, so all these things you can use in a proof either forward or backward, the converse. Okay, so these two, let's put a star next to these. These are sometimes confused because you see the right angle in both of them. So right with 90 is the definition of right angle. Right with perpendicular is perpendicular. Or you can think of it this way. The only time it's ever perpendicular is if you see the symbol perpendicular. Okay. Next, linear pair postulate. The measure of angle 1 plus the measure of angle 2 equals 180. Now this comes straight from a picture. You have to have a picture for this one to be true. So you have a straight line that we of course know is 180 degrees. If you have two angles that form that straight line, then that's linear pair postulate. You can look at that picture and be able to say the measure of angle 1 plus the measure of angle 2 equals 180. Okay. A linear pair, a pair of angles that form a line. That's how you think of it. A pair of angles that form a line, a linear pair. And then we've got vertical angles are congruent. If you have two lines that intersect, the angles that are across from each other are called vertical angles. You should know this already. What we know is that angle 1 is congruent to angle 2. If these are vertical angles, then they have to be congruent to each other. vertical angles are congruent. It's technically the vertical angles theorem, but in our proofs we'll write vertical angles are congruent. So anytime they're vertical, they must be congruent. You can go straight to angle 1 is congruent to angle 2. And all right angles are congruent. The last one, if I say the measure of angle, if I say angle 1 and angle 2 are right angles, if the angle 1 and angle 2 are right angles, then angle 1 must be congruent to angle 2. So what it's saying is that if it's a right angle, and this one's a right angle, then they have to be congruent to each other. Okay? Now, in this case, the converse is not true. No converse. Well, there is a converse, but it's not true. So we're not going to write it down. So if angle 1 and angle 2 are right angles, then they must be congruent to each other. If I said angle 1, angle 2, angle 3, angle 4, angle 5 are all right angles, then I could say all of them were congruent to each other. Okay, so this gives us a shortcut. There's a longer way that we can get through these steps, which I can show you in the steps, or in the proof. But anytime we know two angles are both right angles, we should just go ahead and state that they're congruent, since, of course, that will be true. Okay, we'll talk about We the People Eat Pizza and how all of this works in class, but I will go ahead and give you a quick idea of how this works. Of course, we always put the given in the proof first. Okay. The next thing is the W, the wordy statement. That's where the W comes from. We want to undo any wordy statements. So if a proof has a wordy statement in the given, you want to undo those first. Okay. When you're all done undoing the wordy statements, then you want to go to the picture. Go to the picture and find anything you can from the picture, like angle addition, linear pair postulate, or vertical angles are congruent. Then, once you've undone all the wordy statements and pulled anything from the picture that you can, then you will start figuring out if something is equal to the same thing. So if two things are equal to 180, then you can do substitution. If two things are equal to 90, you can do substitution, or if two things are equal to the same angle, you can use substitution. So we, the people, eat, and then if you can plug anything in for something else, that's going to be either substitution if it's equals, or transitive if it's congruence. So that's We the People Eat Pizza. It just helps you move through the proof with some guidance, okay? And it keeps you moving, hopefully gets you through the proof. All right, so it just gives you some guidance. Now, don't forget for tomorrow, you need to have number 2 and number 4 done on the front. And the rest of this we will do tomorrow in class together.